about that. All right, but yes, Tiz, as you and Sean were both saying, the main attribute of a primary key is that it is unique for every single instance in your database, um, which is what which is the reason why it's called a primary key. So oftentimes people will just name the primary key ID, but I don't like that in general. I prefer to specify it in slightly more detail. So I think customer ID is probably a good move there. All right, so that's our first table field sort of created. So the next thing that we can think about doing is the discount table. So the discount table, I'll just say it, is supposed to store a membership type and a associated discount rate.
Membership type. And what was the other one?
It's supposed to be a discount rate. So like I guess bronze members get 5% off, gold members get 20% off, something like that. So now we need to figure out how to link customers to discounts based on their membership types. So how can we do that using customer profile? Any ideas?
You're asking me, or is that an open question?
Oh, it's an open question. All of these are always open questions. I
We
should
could
have
we
mentioned
should
that.
create a foreign key that links to the customer ID primary key, yeah?
Right? How do we do that?
Um let's see, what do we want? Uh Customer ID, I guess. We could use customer ID again, right? Customer ID, and then that's FK caret line. No, forget the syntax. It's different than when you're
I
writing
think
in
you
the
need to have int, int to give it the data type, and then you do your FK.
FK.
This always messes me up too because it's different from
Oh,
actual SK,
yeah, that's what.
SQL.
Yeah, so it's this, and then it's I think.
Customer dot customer ID, I think.
Yeah.
Is this something specific to this
It
program?
is.
Yeah, it
Yeah.
does a different syntax, which threw me off the other night.
But instead of doing that, you can also click and drag, which is really helpful. At
Wait,
least if I
what?
remember correctly. So
Wait, what?
Yeah, there'd be three dots that pop up. You click on the dot and drag it to a dot. That's how I do it.
Oh, okay.
No,
it
I've never,
helps a
I was
lot.
like
what?
wondering what you were typing. I was like, what is all this?
Does it make it all the way there too? Does it like fill it in?
Yeah, no. Watch last name. I'll drag it over to discount rate. Boom.
Oh
What?
my God. Okay, cool.
Yeah.
Excellent.
So that also that can save you many hours of headaches. Which is the other great thing about programs like this that visually draw out the databases is instead of thinking like instead of thinking, okay, so which one does the foreign key associate with? No, just draw the line and it writes it for you. It's magical. So I highly recommend that. So, but before we keep going, um, what type of relationship do we have between customers and discounts? It is an open question.
The
Most,
one to many?
yeah.
Okay.
Wait.
So which is the one and which is the many?
Customer would be one because it only has one discount, but discount can belong to a lot of customers. So discount would be many.
I would flip it. I would say many customers
Have different
can be
levels.
associated with one discount.
So discount is only
Because
one.
discount is singular.
You only
It's
have
not
one rate.
discounts, right? So
Oh,
it's
I,
like it's not a bunch of items. It's just one discount.
I keep having to reverse my thought with these schemas. That's why it's so hard for me to build.
No, it is hard to do that. But again, the easiest way to think about it, in my opinion, is can you have many discounts belonging to one customer? Or many, a better way to think of it, instead of discount, I don't know why they called it discount. We can just call it membership instead, if you guys think it's easier. It's like, can you have many memberships belong to one customer? No. Can you have many customers belong to the same membership? Yes. So again, the belonging or has or is a like that, if you frame the question in those words, like for yourself, it may help a little bit with answering those directionality questions. So let's see. Trying to, oh, I can zoom in. Okay. So we have customer ID, and what do we all think before we keep going? Is the table that we have so far, does that set up our many to one relationship accurately? This isn't meant to be a leading question. It's a actual
I
genuine
mean, like
question.
for what we have built, does everything look okay? Is that what you're asking?
Yeah, between customer and discount.
Yes.
Is there anyone who disagrees with that?
Wouldn't you need to put a primary key in the discount table and then use that as a foreign key in the customer table?
So in addition to the relationship that we currently have, you're suggesting add in another field and then draw other arrows back?
Yeah, because you'd want each customer record to have a particular membership associated with it, right?
I see your point. So unfortunately, the answer is actually no, but this there's a really good reason for why. So before we keep moving on, Jonathan, would you mind adding in that field for the foreign key in customer and then drawing a link between the discount ID and that field? Or sorry, I think you might need to make a field for discount for the primary key for discount.
Could membership type not be the primary key for the discount table?
You could do that, but the intention was for membership type to be a character field, while primary keys are always integers. So in general, it's always good to have a standalone ID field that acts as the primary key.
So is it supposed to be always integer though? Because it could be like a code. I mean, like ABX and then 001. Like that could be an ID too. So is it supposed to be like a integer all the time?
In general, I believe that's correct. Let me check.
Actually, I mean, in my experience, I've seen primary keys be like a string, like Isam said, where it's like a system generated code that has a bunch of letters and dashes and numbers as well. So it doesn't have to be an int.
Interesting. Okay, cool. Well, learn something new. Thank you guys for sharing that. So yeah, I guess it can be also, I just looked this up as well. So the data type of a primary key should be a numeric, an integer, or a short fixed width character. So I guess integers or strings are primarily what they use. But yeah, thank you both for thank you for asking that, Evan. Thank you for sharing that. Yes. All right. So just so I make sure, Eunice, is the diagram on the screen that Justin drew roughly what you're thinking of when you were
Oops,
asking about?
sorry, I was on mute.
Go ahead.
Well, I guess because the customer profile table is supposed to be the one with the reference to the membership type, I guess we could set it up differently. But my thought was that like the customer table would be kind of the single source of truth for every customer. So one unique record for each customer. And so if we want to be able to identify what customer, like for each customer, what type of membership they have, the discount table would just have like, a membership type, let's say it's like gold, silver, bronze, and a primary key associated with each one of those. And then rather than having like a customer ID in the discount table, you would have the membership ID in the customer table. And the reason for that is because of that one-to-many relationship idea where, because if you start listing like multiple customers under that one membership type, that column is going to have multiple customers in one row, right? And I I don't think that's like a good design. Does that make sense? What I'm trying to get
Yes.
at? Yeah.
Yeah, very much so. I think I was misunderstanding what you were saying originally. So I apologize for that. But yes,
Oh, no,
I
no
think what you're
worries.
saying definitely makes sense. So also, for now, let's forget about the customer profile table. We can just disregard that for now. We'll see about what happens if we need to add it later. But yeah, I think your point, Eunice, is exactly correct. So let's so
I'll just say, can
going
we have
back.
Eunice guide those corrections onto here with Jonathan? Like let Jonathan drive and have Eunice go, okay, hey, line 3, put this out, line 4, put this out, or whatever. Just so we can like straighten this up, or is this exactly how we want it to look? Because if it is,
And
I'm
then, so
confused then.
yeah, I would delete the line 12 customer ID. Yep. And then in line 9, I would put membership type ID as a PK. Mm-hmm. And then yeah, for line 3, there doesn't need to be that foreign key association anymore. Mm-hmm. Yeah, and then I put another field in the customer table that's membership type ID. Yeah, and so that will be the foreign key to the discount table. Yeah.
Okay, awesome. Yeah. So, Sean, thank you for that suggestion, and Eunice and Jonathan, thank you for implementing that. I think this does look a little bit closer to what we're looking for, and hopefully the rationale sort of makes sense. Um, but I think Eunice, you did a really good job of explaining why that change needs to happen. So, thank you for that. Does anyone have questions about why the membership type ID goes in customer instead of the customer ID and the discount are in the membership table? Does that sort of make sense?
Yeah, the idea behind it is if you ever update a discount, every customer's already updated. You don't have to do each individual one.
Yeah, pretty much. And then also again, sort of going back to the relationships. Does a customer have a membership type or does a membership have a customer? Usually it's the first one, right? So because a customer has a membership, it makes sense for the customer to have a membership type ID in the customer table. So the thing that I thought Eunice was referring to before, which hopefully you guys will avoid, is a circular reference. Um, have you guys heard about circular references in SQL tables before?
There was like a recursive reference, I guess, referring to itself.
Yeah. So where you could have a problem is if we kept the existing schema as is, and I'm gonna add some annotations. Can you guys see me drawing on Jonathan's screen? Okay, I'm gonna assume yes, because I know Jonathan can see it. So let's say that we added in a field into discount and we called that customer ID. So let's assume hypothetically that we wanted to set up a one-to-one relationship between customer and discount. So you might think, all right, well, the I can link them both based on the discount ID, but I can also link them both based on the customer ID. This is a problem. In general, when you have two tables, you only want to have one foreign key linking both of them. You do not want to have two foreign keys linking between two tables. Because if you think about it, let's say that you have customer ID with customer ID 1. Then that customer ID 1 also shows up in discount. But then that customer ID is then referring back to customer 1. So you're kind of going, if you're trying to examine the relationship between a customer and a discount entry, you don't end up going from customer to discount or from discount to customer. You're able to go from the customer to the discount at their ID. But then, because that is linked to a membership ID, which then goes back to customer, which then you basically get a loop relationship where you keep going, bouncing back and forth between both tables, which you always want to avoid. So the main point of me saying that is you should only ever have one line drawn between one table and another table. If you have two lines drawn between them, you need to remove one of the lines, and it's your job to figure out which one to take out. But we haven't done that so far, which is good. So, does that make sense though? Are there any questions about why we would want to avoid that?
I have other questions about the changes we made, and I don't think either way is right or wrong. I think it's just a difference in what we intend at the end. But like, if we remove the customer profile, we're essentially saying that we're not going to make any changes to customer profile tables, and that because if we do, then we're going to have to change the entire customer table. Additionally, what happens if a customer doesn't have a profile?
So,
So
so the customer profile table was intended to link between customers and discounts in the original schema from the assignment. So that was the only purpose of that table existing, if that makes sense.
I think so. We'll see.
Okay. Um, Also, there isn't, well, no, there are blatantly wrong ways to set up database schemas, but in general, there isn't one singular correct way to do it. There may be two or three that are fairly close to each other. Oh, Eunice, go ahead.
Yeah, I just had an idea about what Justin was saying is, another option to work with that is to add a membership type in the discount table where it's like a no profile or kind of like a base membership type where it's a default membership type where any customer that is created will just default to that type. And then if they do decide to like subscribe up to a gold, silver, or whatever, then that table, then discount will get I mean, not discount, customer will get updated with whatever they decide. So you can still track, who has a profile, or whatever you want to call it, versus those that don't.
Yeah, I think that's a really good idea. And the other nice thing about SQL, and then also when we get to Django, which we use to build our backend, setting default fields is really easy. So if we were to do what Eunice suggested, which I think is a good idea for sure. When we initiate a new customer, we could just set the default membership type ID to be that, blank or no membership uh, entry, which would work pretty well. Any other questions about the relationship between customers and discounts before we move on to orders and items? All right, so let's start with orders. So can a membership be directly tied to an order? Open question.
Yeah, if a customer is creating an order of items, you're ordering a bunch of stuff, right? So what falls into that order? Should be like one order to one customer, so that'd be a one-to-one.
Can a customer have several orders?
Oh, true. Yeah,
I mean, I don't know. I haven't read the README or anything. That's a genuine question. Like, I don't know if that's a thing or not.
that makes sense.
If it makes sense, that probably is. So
Well,
let's assume
customer
that one
one,
customer can have multiple orders.
so the customer would be one, and the customer order would be many in that instance.
Are you sure that we can't have the reverse as well? Can we have one order belonging to many customers?
That
Typi-
wouldn't,
Typically,
well,
no.
Yeah, because where's all the money coming from? Like multiple different people? That doesn't make sense to me.
Yeah, that would not work. So you all are correct that this is a one-to-many relationship. And I think as you both correctly identified, you have one customer can have many orders. So based on that information, let's Jonathan, could you add in a primary key field into customer order, just so we have one to reference? Thank you. Okay, perfect. So which way does the relationship, will the arrows in the relationship go? So based on the mini exercise we did with discount and customer. Now we're going to do the same thing with customer and customer order.
So a foreign key from customer ID, right, would be referencing customer ID.
Go from where to where?
Customer ID to customer ID.
So Justin, are you suggesting we make a new field in customer
Yes, I'm
order?
sorry. I'm on a laptop, so I'm like trying to see everything at once. Yes.
Very good. Also, you can zoom in to see the screen larger by zooming in with the touchpad on laptops
Oh,
in
that's so
Zoom.
awesome. Thank
I
you.
only discovered it last week and it is a lifesaver. Unfortunately, like the plus and minus buttons do not work very well, but touchpad does help. Okay, so yeah, Justin, I think you've got a a good idea there, but why would we want, just to hammer the point home, why did you suggest to put the customer ID in customer order and not vice versa?
Because we want to see the way I have the table built is I want to have an order ID, a customer ID, and then I want the reference of customer. I want to, with customer ID and the cust order table, I want to reference the customer who placed the order. So from there, I would go, like I said, from customer ID here, which would be our many to one. So we'd go from left to right in this case, or right to left in this case. We'd go, because we're doing the opposite, we're doing many to one. Is that what you're looking for? Is my
Yes.
okay?
And actually, yeah, yep, no, that's yeah, that matches up. But does what Justin said about the directionality of the many to one make sense to everyone? Any questions about that?
So unless it looks like the origin's like 3 branches and then the direction's a cross at the end or something like that.
I think that's correct, yeah. The notation is a little bit confusing. I wish it was slightly clearer, but okay, so now for the last one, which is always the fun one, and I'm curious to see how you guys think we should tackle this. So again, before we start drawing lines, the first thing to do is add a primary key to item. And then the next thing that we should do is think about what relationships exist. Excuse me. What relationships exist between item and our other tables? So can item be related to discount directly?
Yes, but it would be 1 to 1, correct?
So why would we want to link? So this is going outside of the database and going into the real world, or I guess the fake real world we've set up for this grocery store. Is there usually a relationship between like a grocery item and like the membership you have when you go to the grocery store? Not really.
Thinking like Costco, no.
Yeah, exactly. So because of that, we are not going to put that relationship into our database. We can do the same thing for, is there a relationship? Again, apart from when you get your receipt or if you've ordered something, is there a relationship between you, the customer, and the item on the shelf when you go into the grocery store? Not really.
So that
But
depends. That could depend, right? Because you could add that to a list of purchases or something, and that would be by customer ID.
that would be customer order. So you just answered my last question. Is there a relationship between the item and the order? And the answer is yes. So what is that relationship? Is it a one-to-one relationship between a customer order and a item in the grocery store? Can you have many items in one order? Or can you have many items in many orders? Thoughts from the group?
It sounds like a many to many because many different orders can have multiple of the same item. Is that what we're saying?
Can you
And
make
then
multiple orders at once?
So for argument's sake, let's say that an item is not like an individual like bottle of water or something, but it's like a category or like a type of item. Like, cereal box.
a shelf
Or
of apples.
yeah,
I can have multiple apples in one order. I have
yes.
multiple orders with multiple apples.
So can you have multiple orders with multiple items? Like Sean, what you just said makes sound like the answer is yes. And can you have multiple items being in, or can you have the same item be in multiple orders? I can buy an apple and you can buy an apple. So it sounds like yes. So we have a many orders can have the same, or one order can have many items, and one item can be in many orders. So when you have that type of relationship, that's a many-to-many relationship, which I believe one of you guys said at the outset.
So then we're saying apples all get the same item ID.
Yes.
Got it.
Yeah.
It's not apple
Shiv,
01, 02, 03. It's apple.
exactly.
Okay.
Yeah. That being said, we could have designed it so that every single item of inventory in the entire grocery store got its own ID. In which case, you would have well, what type of relationship would you have between customer order and item in that case?
See, this sucks. Because there's so many different ways to do this.
Yep. And again, a lot of it is up to your individual implementation or up to what the client wants. So, for example, if you are designing this database for Costco, where they have quite literally a million items in every single store, and let's say I don't know how many Costcos there are around the US, I'm going to say there's 1,000 Costcos. Your database will then have, if you were to make a individual ID for every single item in every single Costco that was unique, you would probably have like a billion rows just of items in your data set, which would be terrible. 614. Okay, that was that was close. I'll take it. That is still a lot of Costco's. But that's a huge database. No one wants to deal with that, especially if it crashes. So presumably what you would do instead of having one ID for every single item is you would have an item ID for the general type, like Sean said, apples or Fiji apples or red apples or something like that. And then you would add in an integer for inventory. And then that would get subtracted or added based on how many people had ordered it or whatnot. But again, it's very possible that they could add individual IDs for every single one. So the only way to really know that is what the assignment, or again, outside of assignment speak, what the client tells you to do, which can complicate your implementation. But all right, so let's get back to the task at hand. So Sean and Justin, both of you guys identified that we need to establish a many-to-many relationship between customer order and item. Let's see. Daryl, would we be able how can we create a many-to-many relationship between customer order and item? Any ideas?
I'm not sure how to do it directly, but can we create like a junction table?
Yes, and that is the correct way to do it. So in SQL, the only way that you're really allowed to create a many-to-many relationship is by creating a joining or junction or a table. So Jonathan, would you mind doing that for us? And then Daryl, if you want to, sort of guide us through that process.
Like a
Sure.
order items table.
Yeah, we can do that. The table could be called ordered items.
So just nomenclature wise, usually when people are making a table for many to many, like to link them, they'll usually just combine the names of the two tables that they're creating a many to many relationship between. So in this case, you have table of orders and table of items. Order items generally works pretty well.
I guess we
Thought
can
I,
have
thought I was being smart there.
a customer order ID. I don't know if this is right.
That's a
And an
good start.
item ID. I'm assuming they would both be foreign keys.
It would need its own ID to reference that table.
You need like an order item ID as the primary key.
And then I guess we
I think,
can make the
oh,
customer
good.
order ID a foreign key. Would that work?
Yeah, so I think the ordering of the arrows there needed to be flipped around. But otherwise, I think this is exactly what we're looking for. But yeah, all right. So Daryl, thank you for walking us through that, and Jonathan, thank you for implementing. Um, so we have successfully been able to connect all of the tables in our schema together. So the way that I like to sort of check myself when I'm looking at a database is to make sure that every single table has a link or can be connected to every other table somehow. So, for example, in this case, we can go from an item. If I ask you for an item, or if I tell you, hey, find out which customers ordered um an apple today. You can go to check what the item ID is of an apple, and then you can link that, or you can go, then using that, we can go through and check order items to see which customer orders that item showed up in. We can go through the customer orders and then link that to the customer IDs of aka who ordered those items, and then we can return the customer information. So again, that's all because of the relationships that we've set up so that we can go from item to order items. And order items, we can check what orders include those items. And then we can check which customers made the orders that include a specific item we're looking for. But that's really about it for our schema design. Um, So, Jonathan, thank you for being willing and able to share your screen and walk through the process with us. Um, let's all give Jonathan a round of applause for going through that harrowing process. Um, does anyone have questions, comments, concerns about anything that we walked through together?
How big of a deal is it to make changes to schema once you've already kind of laid the footprint? Is it not a big deal, a huge deal?
It depends. So, I remember once I was working on a project a few years ago where I started with a very simple database that had maybe like three tables, and I populated it with some initial data just to play around with it. And then later on, my client said, hey, just so you're aware, our requirements have changed because we forgot to tell you a bunch of requirements. We need you to add 5 different fields, add in a bunch of different uh, checks, like on to, for example, certain things could not be null anymore, certain things had to be divisible by insert numbers, etc. Go and implement all those changes using your existing data. And that was absolutely painful because first I had to make sure that the data wouldn't get corrupted when I changed things in the database. Then I had to change the fields in every database while hoping that the relationships between the tables still stayed the same. And yeah, moral of the story is don't add data to your SQL databases until your schema is 100% finalized. Or if you do add data to your SQL database, make sure that it is just like dummy test data that you do not care about. Because if you need to change the relationships in your database after you've put data in there, you may, if you aren't extremely careful, you may need to wipe the whole database. Because the one problem that SQL has is it will sometimes glitch out on you and think that your old relationships are still in play, even if they aren't, and then you just need to wipe the whole database. So in conclusion, Justin, yes, it can be a big deal, especially when it comes to relationships, But let's say that your changes ended up being, oh, I just needed to add 5 fields that don't interact with anything. Then you're probably okay. But I would always be very cautious about that just because, and especially when you get databases that have maybe 10, 15 tables, very complicated looking diagrams, you might not recognize, oh shoot, this field is related to that one with a foreign key. It's okay if I make a change. No, it definitely it will not be. So be very careful about that. But does that answer the question?
Yep, sounds like a nightmare.
Yeah, it can be. But yeah, that's also where backing up your SQL database schemas is very important. Because sometimes you can design a schema that works with one version of your code. You then get instructions to modify the schema, or you decide to revamp it a little bit, and then everything ends up breaking, and you want to go back to the original version of your schema. Save your SQL code. Even if the data is lost, it's okay because that data should have been test data. But save your SQL schemas. It will help you a lot in the long run. Other questions about this database or just database design broadly speaking?